Hello everyone, so today we are here with a new problem and the problem name is 132 pattern. So it is a medium problem and I also feel it is between medium and hard one. The logic is very great and we need to understand this problem. So let's come into the problem description. So problem is we have an integer array and there is a pattern, 132 pattern is there, right? So 132 pattern is a subsequence of three integer like 1, 2, 3 which is I, j and k such that the ith element comes before the jth and the jth element comes before the kth element. Okay, and the element which comes at last should be greater than the element comes at first. Similarly, the element comes at the second position should be greater than the element comes in the second position. What I mean by this, if you see this 1, 3, 2, this I comes first, right, and then this j and then this k, and what we want, this 2 should be greater than this 1 and this 3 should be greater than this 2. If any of the subsequence we find in the given array, we have to return true. Okay, it means it follows this pattern, otherwise we have to return the false, right? Let's take an example and understand it very carefully. So let's suppose this is the array we have, which is 3, 1, 4, 2. Now in this case you can see that 1 comes first, then 4 and then 2, and if we take 1, 4 and 2, right, and if I take like I, j and k, so is it follows the 1, 3, 2 pattern? Let's see what this pattern says. The element which comes at last should be greater than the element which comes at first, and the element which comes at second should be greater than element which comes at last. So yes, 2 is greater than 1 and 4 is greater than 2. This thing follows, and that's why it follows the 1, 3, 2 pattern. One more thing we have to understand from one example. If you see this test case, you can see that for this example we have a lot of different subsequence patterns are here which follows the 1, 3, 2 pattern. It means minus 1, 3, 2, right? And if we not consider 2, we can consider 0. Similarly, we not consider 2, 3, we can consider 2. So subsequence means a discontinuous part of the array. So we can take the discontinuous part of the array. Okay. So from this, the very brute force comes to everyone's mind is what we can do is we can take basically 3 pointers. Like we can take one pointer here, another pointer here, and one more pointer here, which iterates the rest of the array element, right? And for each element, we will going to check these conditions. If any of the subsequence follows this condition, we can basically say that it is true. Other than that, we can say this is false, right? Like how we can take this? Let's suppose we are taking 3, 1, and 4. 3, 1, and 4. Now we can say that this 4 is greater than 3, but this 1 is less than 4, which not follows the 1, 3, 2 pattern, and it is not our answer. Then we can take this pointer, move here. The next is 3, 1, and 2. Now we can check this. This 2 is basically not greater than that, so it is not following the sequence. Now what we can do is we can basically remove this pointer, right, and take it there, and the another is 3, 4, 2. Then we check for 3, 4, 2, and it also not follows this pattern. Then we will come out of this, and we will move this by this pointer. This is this pointer, and this one is this pointer. Now when we take 1, 4, and 2, now 2 is greater than 1 and 4 is greater than 2, which follows the pattern, and we can simply return true. But the main thing is, what is the time complexity here? So for each pointer, like for this pointer, we are iterating the rest of the elements, and for this pointer, we are iterating the rest of elements. So we are basically using 3 for loop, and hence its time complexity is big O of n cube, which is not a very good time complexity, right? And it will also give you TLE error, which is time limit exceeder error. Now, how we can solve it? So let's understand this problem, like what is happening here, and how we can basically optimize our problem. Okay, so if we see this very clearly, what is happening? At any point of time, we basically think of some kth element, right, which is greater than some ith, and the gth element is basically greater than this too. So we have to find these 3 integers, right, which follows that pattern, right? So here you can see there is one element, the first element, which is the very minimum element we have. This is the very minimum element we have, right? And this one element is greater than that, and the another element is not greater than that, right? So if at any point of time we can figure out this I and we can figure out this k, right? And let's suppose this one is there, and then we have this 2, right? Then if we have 4, we basically can see whether it follows this pattern 1, 3, 2 pattern or not. Okay, what I mean by this, let's understand this. Okay, so what I do is, this is the array I have, and I'm going to use one stack. Okay, to solve this problem, to optimize this problem, I'm going to use one stack. And what this stack does, we basically use a mono monotonic decreasing stack, right? So monotonic decreasing means which follows a decreasing pattern. We are going to save the value in the decreasing fashion. How? So let's suppose this is the stack, right? And let that stack is empty and we are going to push 3 here. Now when we add 1, so this 1 is basically less than this 3, so it is going to decrease, right? So we can basically add this 1. Now when you see this 4, you can see this 4 is basically greater than 1, which is not following this monotonic property. So we are going to pop it up, and then we are going to pop it up, and then we are adding 4. Now you can see we have 2, which is less than that, so it is following the property. Now one thing here, this 2 is basically less than this and this 4 is greater than that. That is fine. But this solution, in order to create this solution, we also need this 1, right? What it means? It means we basically have to save at this point of time when I am iterating this element in the stack, what is the minimum element? What is the minimum element we encounter before this point? We also need to store it somewhere. Like at this point of time, the minimum element we have is 3, right? At this point of time, the minimum element before it is what? Is 3. And at this point of time, what is the minimum element we encounter? It is 1, right? Now, if you can see this, at any point of time when you try to push this, you can see that this current element, which is 2, this current element is less than this 4 and is greater than this 1. And if this condition satisfies, we can simply say it is true and it follows the 1, 3, 2 pattern, right? Let's take one more example and understand it. -1, 3, 2, 0. Okay. So the array is -1, 3, 2, and 0. So what I do is I basically take a stack, and at each point of time we are also saving the minimum element, right? Now the stack is empty, so we are going to push -1 and the minimum element till that point is -1. Now when we are going to push 3, it is greater than that, which is not following the monotonic stack property. So we are going to pop it, but the minimum element is remain -1. So we push 3 and the minimum element is -1. Now when we reach at this point, this is 2. Now we can check, is that 2 is less than 3? Yes. And is that 2 is greater than -1? Yes. And that is what we want. In that case, we get a 1, 3, 2 pattern and we can return true. And thus -1, 3, and 2 is the answer we have. And that is how we are going to solve this problem, right? So I hope you are understanding this problem. Like what we are doing previously, we basically use 3 pointers, okay? And each pointers store some value in it, store some important information in it. And that information we are storing using this one stack, and this one pointer at any point of time, we will take this pointer and we can, whatever the 2 values we save, we can simply compare. We don't need to save each value, right? And that is how we are going to solve this problem. We basically at 1, 3, 2 pattern, you can see there is one value which is very small, right? And there is this is the decreasing pattern. 3, 2 is a decreasing pattern which we maintain using this monotonic stack, okay? Like if you see this pattern from there, you can see that 3, 2 is a decreasing pattern. That's why we are going to use this monotonic decreasing stack, and this minimum value is used to save this minimum value. And if any current element follows this pattern, we have to return true. Other than that, we have to return false. Now let's see the code for that. It is very same. So let's see this. Okay. So we basically take one empty stack like here. I think it is not working. That's fine. So this is one stack we are using, and this is the minimum value. So we consider the first element as the minimum value element, and we iterate from the second index. So if the stack is empty, or if the current element is greater than the element which is present at the stack, right? So you can consider the value saved in stack like this. This is the element we have, and this is the minimum element present at the left side, okay? So what we check, if the element which is at the peak of the stack, if it is less than the current element, then we are going to pop it, right? So there is only one case when we come out of this while loop, which is this current element is less than the peak element, right? That's why we are not checking that condition. And what is the another condition we have to check? We have to check the minimum element should be less than the current element, right? This condition. When we check this 2 is less than 3, the another condition we have to check, this 2 should be greater than this minimum left element, right? And that is here we are saving it. Sorry. Okay. And we also have to append the elements if none of the condition follows. In that case, what is happening? The current element is the decreasing pattern element, but it not follows the 132 pattern. In that case, we have to push in this stack, and we also have to update the minimum till now. And in this while loop, sorry, in this for loop, if we are not getting this solution, it means we have to return false. There is no such solution. So thank you, and if you like this problem, please hit a like, share, and subscribe. Thank you.